Hey everyone, my name is Wes Hutchins. I'm a product manager on the Google Cloud Platform team, and I'm excited that everyone's here today to join for this track. We're all about the developer-focused track here, so we're going to be taking you guys through demos, show you how to get set up on your local dev machine and start building some apps on top of Google Cloud Platform. I did want to make a little announcement. When we were running through this the other day, there's not a lot of room for us to stand up here, so we actually found ourselves walking in the middle and blocking the screen from everyone. So if I ever get in that situation, just somebody do this, and I will happily move off to the side of the stage. So today's track is all about building an app from start to finish. Typically when we come and do presentations, we talk about specific features and we come in with very complex and pretty complete sample applications. But we heard from a lot of customers that they just wanted to start from scratch. Do something from the ground up and take it all the way from idea all the way to production. And so that's what this track is all about today. We're going to be building an app, talk about what the app is, take it from idea, take it into prototype, release it to production, and then the last session is actually going to be looking at optimization of that application. What are users actually doing with the app once it's out in production? So we've broken this down into 4 talks. The first one is this talk, which is Design Your App. And it's really a broad overview of the technologies of Google Cloud Platform. It's a little bit of a talk about everything. So I'm going to try to see if I can condense that down into about 40 minutes. But I really want to leave you guys with what products we're using on top of our platform for building out this application, when is the right choice for your app, and go through some of the ideal use cases for when you should decide which product to use. And then the next session, Build Your App, is all about building your application. So we're going to be demoing for the entire session. It's going to be talking about the architecture of the application, getting you set up locally with your development environment, and then hopefully by the end of the session, we've built a ready-to-run application that we're going to go and upload to production that you guys can then go and download and play with. Once it's up there, we're going to teach you guys what to do when it's in production. And you need to deploy and monitor and operate on your application as it's running and serving user traffic. So this session is going to be all about the features that talk about continuous deployment and gradual rollout of features, traffic splitting. And then we're also going to cover things like monitoring and logging and show you some of the cool log integrations that we have on top of our platform. And we're even going to bring in a few partners to tell you how they use our monitoring tools to go and look at their application as it's running in real time. And then we're going to wrap it up with a session called Optimize and Analyze. And this is our big data session. So we're going to be trying to take a bunch of logs data and figure out what our customers are doing with it. So you have something out there, you want to see what users are building or how users are interacting with your application, and then use that data to actually make improvements to your app. So that's all going to be in the 4th session, Optimize and Analyze. So what app are we building today? The name of the app is called Abelana, and it is a sharing app. Abelana means sharing in Zulu, and sharing is really the heart of what this app does. It's a feed application that allows you to upload a photo to a bunch of followers and then have them like or upvote those pictures. So I want to switch over just to give you guys a quick 2-minute introduction to the application that we're going to be working with today. Okay, so let's go ahead and launch the Abelana app. And what I will see now is an activity stream. So when you go and launch the applications, we're going to pre-populate a set of followers for you. But this is just pictures from the event in GCP Live today. And it allows me to actually go through these pictures, like them, and then that information shows up on a list of followers. So let's actually go and see if this works. I'm going to take a picture of you guys in the audience. Everyone's waving. Nice job. And while that's uploading, I just want to show you a little bit more of the features. If I go back to the Following tab, I can then see all of the people that are following my feed. So what will happen is this application will be uploaded to our cloud app, and it'll be streamed out to all the other people running this device. They will then see it on their activity stream and give them the opportunity to upvote it. So hopefully as this thing is loading in, you will be able to see, there we go. So that is the picture of you wonderful people, and I'm going to go ahead and like that. And that's the app that we're going to be building today. So it's not too complex. It touches on a variety of features on Cloud Platform, but we're going to be walking through this from start to finish today. So a few technical features about the app today. Obviously, it's an Android app. We wanted to build a mobile application. We see a lot of people building mobile apps on our cloud, and all of the concepts apply to web apps as well. But we wanted to show you guys what it was like to actually work with Android and cloud together. And one of the cool things about this app is it uses a variety of Google platform services and technologies. So we use things from compute, we use things from storage, and we use things from our big data set of products. We also are going to be integrating with the Google Identity Toolkit, and this allows people to sign in using Google+, Yahoo, and a couple of other providers. So we'll work through the identification options you get out of the box with the toolkit. And then all of the material that we're going to be covering today is going to be available on GitHub and in the Play Store. And after the second section, when we actually go and publish it, you guys should be able to go and download the app. So, as I mentioned, the Abelana app covers a variety of different products and services that we have on cloud, and this is going to be my focus of the talk today. I'm really going to focus on compute and storage, and then in the last session, we're going to focus on some of the big data products. Now, this is an overview of the Abelana application. We're going to go into much more detail in the later sessions about what's going on here, but I wanted to give a high-level overview of what the app looks like. So on the front end, we have an Android application that talks to an Abelana server, and the server is responsible for handling all of the requests that are coming in from the app. This returns things like the photos from the feed, it returns metadata about what information is liked, and then all of that information is then stored in Cloud Datastore, which we use in conjunction with App Engine to store metadata about the information that's getting returned to the Android app. You notice that I was able to upload a picture, so those images need to be uploaded somewhere. We're going to be using cloud storage for that. And then finally, we're going to be using Compute Engine on the back end to process and resize these images so that they're optimized for display on a mobile device. But I want to start from the beginning. So let's go through some of the compute options you have on Google Cloud Platform. Where should you run your application? Well, you have your choice typically of infrastructure as a service, which is our Compute Engine product, or platform as a service, which is App Engine. And really, the choice is up to you as the developer to try and figure out what level of flexibility and agility are you guys comfortable with. So Compute Engine is nice in that you can go and spin up VMs, you can SSH into them, you can install whatever software you want, but it has the downside that you have a little bit extra management overhead for your application. For the platform as a service offering App Engine, it's great. It gives you all the building blocks to build an app from start to finish really, really quickly, but it does have some limitations. So you don't have as much flexibility as you would have if you were managing everything yourself. And with Abelana, the best part is we're going to actually use both of these. So we're going to show you that you can build cloud-backed applications that rely on both App Engine technology and Compute Engine technology. But regardless of whatever choice you make, one of the cool things about building on top of Google Cloud Platform is that you're actually running in the same data centers that we use to power our apps like Search and Android and Maps. And this really gives you the reliability and scale of running on top of Google hardware. So the first product I want to talk about is App Engine. And this will be just a general overview of what App Engine is and how you can use it inside your application. So this is a pretty typical example of a serving stack. You have your app code, you have your libraries, you have an app environment, which is typically a language runtime, an application stack, and a web server. And then you're running on top of a kernel, which is all hosted inside of a hypervisor VM. But when you actually push that to production, you need to probably scale that. So it's rarely a single instance. You typically have multiple instances. And in order to serve traffic to all of those, you need to set up a load balancer. But then you need some scaling options depending on the number of users, so you also put in an autoscaler service on top of that. But your application is rarely composed of one single stack all in and of itself. It's typically a set of microservices. So you have things like a front end, a feed aggregation, a database server on the back end. So then you need to build out those separately. And of course, they have their own performance and scaling characteristics as well. And because you probably want to run a global application, you need to go and replicate this across a number of zones so that it serves traffic with very low latency for all of your users across the world. And as you can kind of see, complexity emerges pretty quickly for this type of scenario. And I haven't even begun to cover some of the other things you need to think about from an operations perspective. Updates, rollouts, rollbacks, these are the types of things that you have to manage if you're running your own cluster or set of servers for your application. And that really is the heart of what App Engine is trying to solve. We want to be the platform as a service so that you guys don't need to worry about it and you can focus on just writing your application. So App Engine is pretty much you write the app, you deploy it up to our servers, and we will handle scaling and load balancing and updates and traffic splitting and all of that functionality for you. They are really easy to build, easy to maintain, and easy to scale applications. Now, because of this functionality like we provide out of the box, there are some constraints that live with that. And we do support several popular programming languages like Python, Java, PHP, and Go, and we're adding more along the way. But if you look out under the hood a little bit more about what's going on with App Engine, as I mentioned, all of this global cluster management is done inside of Google. It's running on our containers internally, and we give you a sandbox environment for you to run your application. So you really only need to worry about the app code and libraries. But it does come with a few limitations that I want you to make aware of. Because you aren't actually accessing the underlying VM, you don't have access to a file system. And because we need to contain the runtime, we don't allow certain types of extensions. So we don't allow C-level extensions for Python, there are some common extensions out there, and developers really want to be able to do that. However, to make up for this, we give you a set of services out of the box that make it super easy to add this type of functionality to your application. So we give you a data storage service for persistent storage. We give you a mem caching service to allow you to rapidly cache information so you're not always making trips back to the data store. We give you URL fetch, sockets. There's a ton of other services that come out of the box on App Engine, and these are really the building blocks for your application. And with App Engine, you only really pay for the traffic that you use. So in a normal production server environment, you typically over-provision. You want to make sure that your app can handle normal load, but you also want to build in some tolerance in case you get spikes. And that's really what App Engine was designed to solve. So when you get, let's say your app goes public, you get on the front page of Hacker News, or you're featured on the Play Store, you're going to get a steady spike. And if you haven't thought about how your application scales ahead of time, it's quite likely that your app is probably going to fail. But if you're running on App Engine, we handle a lot of the scaling for you automatically. So as we see an increase in traffic to your application server, we will start spinning up other instances. And we will use our front-end load balancers to actually connect these to those instances. So it's a really nice, efficient way for us to scale your app. And then once the traffic starts to die down, we'll deprovision those services. So you're only ever paying for the amount of resources that you're using. So why are we using it in our application today? Well, App Engine is a really, really, really perfect example for hosting a backend that talks to an Android application. So we're going to be using this to give us the scale that we need so that if we ever do release this into the wild, as we will at the end of the day today, you guys should be able to use it. We can probably even watch in real time as the application performance starts to spike. And that really is the benefit of App Engine, is we're just going to focus on writing the code. We're going to deploy it up to App Engine. And then we're going to be able to use our application with a number of users. But we're also going to be using compute in this. And I want to talk a little bit about our infrastructure as a service product compute engine. So in short, these are virtual machines. They're high-performance virtual machines that run on top of our infrastructure. You choose the amount of hardware power that you need. You choose the regions and zones that you want to spin them up in. You choose what operating system you want to run. And then they're yours to manage. So you would SSH into it. You install whatever software you need on top of it. And you would run on top of Google's network, which is really great for building global distributed applications. So you get lightning-fast network backbones that are the same that we use internally for powering our applications, like Maps, Search, et cetera. But I want to talk a little bit about some of the other advantages of running on Compute Engine. The first is we offer some pretty easy choices when it comes to instance types. So we have our standard offerings, which give you a nice balance of CPU and memory. If you want to go even higher than that, we offer high memory and high CPU options. We make it really easy and clear how much memory, how much CPU power you get. And then if you really are just trying to prototype something and you want to just test it out and kick the tires, we also have our shared core instances, which are small and micro for basically the early stages of a product, just to get your feet wet before you migrate to a higher end instance. The second thing that we've talked a lot about, and I'll just repeat it here, is sustained use discounts and sub-hour billing. So all billing on top of Compute Engine is done in 1-minute increments and with a 10-minute minimum. So this really gives you guys the flexibility to spin up servers for small jobs, spin them down, and not have to pay for the full hour of usage of that VM. But sustained use discounts is probably also a unique feature to Google. And I think I need to update these slides after the price cuts. So this was done pre-announcement this morning. But really, the idea behind sustained discounts is that as you guys are using the VM, if you continue to run it throughout the course of the month, we'll give you discounts on that VM. And really, this is about if you have a stable workload, it helps us plan our capacity better, and we want to pass some of those savings off to you. We think that it should be automatic. You shouldn't really worry about locking in reserved instance pricing for a very long time, and that's really what we try to build out with the sustained use discount program. So I want to run through just a quick example just to give you guys a little bit more clarity on what's going on here. So imagine you're running an application, and you spin up a server, and you let it run for 15 days. And then you go and check your log files, and you see an improvement you can possibly make. You said, all right, well, I want to try that. I think I can make something a little bit better, a little bit faster. And you don't want to take down your existing instance, so you do a bunch of refactoring, and you launch it in a second machine, and you use some traffic splitting features to push it off to VM number 2. And you find it's a great success. So you go and spin down VM number 1 after a few days of testing on VM number 2, and then as your traffic starts to grow, you spin up another VM, VM 3, at the end of the month. So what does your pricing actually look like? Well, we end up playing a bit of Tetris. We start chopping up the VMs, and we figure out how many full VMs you've run over that month and then scale back from there. So if you take a look at the different slices that we have, we take some of VM 1, we take some of VM 2, and we push them together, and we say, well, you were running a full VM for the entire month. We're going to give you our maximum sustained use discount, which is 30% off of your instance cost for the month. But then we'll take the rest of it, add it up together, and then you get a discount of 10% if you're only using half of VM for a month. So once again, this is all done for you automatically. You don't need to do as much planning. When you need a VM, it's ready to go for you. And Greg in the keynote mentioned something about live migration. I just wanted to once again touch on that. For those that don't know, live migration is the technology that we use at Google to keep your application up and running when we are doing planned maintenance. So one of the cool features about Google is we're constantly upgrading the hardware because we actually use this internally, so we want to make sure we're always running on the latest and greatest. But we don't think that you should have to actually go and shut down your machine, migrate over to another region, and then spin it back up. We offer this feature called live migration, which takes all your VMs, all of your disks, and port them over to a new region seamlessly behind the scenes. And we actually ran a test when we were rolling out this feature with one of our partners, RightScale. And they went and spun up a pretty typical customer cluster. They had 10 PHP servers with a reverse proxy load balancer in front, talking to a MySQL master and slave database. And then they told us to flip the switch, to turn on the green light. And we did. And they waited 2 hours, and they checked their logs, and nothing had changed. And they came back to us, and they said, did you guys do it? And they said, yeah, we actually migrated your machine twice. Once to a new region, and then back to the same region. And they had no noticeable performance impact, and they didn't even know it had actually happened. So the feature works as advertised. It just makes it really easy for us to upgrade our hardware without impacting your guys' applications. And all management of Compute Engine is done through a nice, simple HTTP and REST API. And this is the same API that we use to build our Cloud Console and our Cloud SDK. So you guys are using the same interface that we do in order to spin up virtual machines on your behalf. So this is a quick little example of what you would do to spin up a VM. You would go and authenticate with us. We'll do a little OAuth handshake. And then once that's done, you can use the gcloud compute command to run a bunch of commands over instances, create disks, attach disks to running instances. those types of operations. So it's a really nice way for you guys to interact with it from the command line or in your application. It's a really simple and easy API. Now, one of the things that we've heard from a lot of customers is that we offer some VMs out of the box, but you still have to go and install the stacks yourself. Well, today we're announcing something kind of cool. We are partnering with Bitnami. I don't know how many of you guys are familiar with Bitnami, but I've been using them for a few years. And they're a really great company that specializes in creating isolated application stacks that you can deploy on virtual machines in the cloud or run on your local machine. So they make it super, super simple for you guys to get an application or a development stack such as Node.js up and running as fast as possible. And now I'm going to actually demo this integration that they have on our platform. Great, OK. So if you go to google.bitnami.com, you will be taken to the launchpad for Bitnami. And there are over 100 open source applications that they provide out of the box with single click installers to get these up and running. So you'll find things like variety of applications like WordPress, there's GitLab on here, they're setting up a LAMP stack. And for the purposes of this demo, we're going to install a mean stack. So this is Mongo, Angular, Express, and Node.js running together on a single machine. And I just want to show you guys how simple it is to get it up and running with this. I clicked on the launch button. It's going to take me to an OAuth page where I will give it access to my cloud account. And then once that's done, it's going to ask me for my project. And this is a Google Cloud Console project that I went and created earlier. And I enabled billing because I wanted to be able to spin up virtual machines. But it's called Bitnami GCP Live. And once I give it that, it will handshake with my project, get the right credentials from it, and allow me to deploy these Bitnami images on that Google Cloud project. So this is their interface for spinning up virtual machines. I'm going to give it a name. I'll take their example name, my mean server. I can see the project it's on. I can choose between a solid state disk or a magnetic disk. I can increase the disk size right from here. And I'm probably going to bump up the server that we have to an N1 standard 1. And then I will hit Create Virtual Machine. So Bitnami will take this image, use our Compute API to actually go and provision a machine for you. And then eventually, I will be able to go and manage this on our cloud console. But it's going to take a little while to get set up. And I wanted to show you guys one of the reasons I really like Bitnami is that they make it not easy. They not only make it easy to get it up and running in the cloud, but they make it super simple to have a local installer. So if you look over here on the right, they provide installers that are native installers for your operating system. So they have OS X installers for Mac. But they also provide virtual machine images for things like running on top of VirtualBox. And they even give you an option for running this inside a Docker container. So if you go and click this and download and install the application, they give you a really nice GUI management interface to go and interact with this app. It's all installed into an isolated directory. In fact, I can go in, click on go to application folder, and it will take me into my directory. I can spin up a terminal window here, and I have a fully running Apache instance with Node, some PHP, a MongoDB server in here as well. And if I want to manage it from the Bitnami UI, I can click over here on Manage Servers. Oh, it was locking up on me a little bit. But anyway, if you click over on Manage Servers, it gives you a nice interface for being able to start, stop, and view the application logs for specific VMs. And I've clicked on the Go to Application button, and I can actually see that I do have an Apache server running on my machine on localhost serving a Node.js, a mean stack on top of everything. And one of the other kind of cool things that they give you is if you go into the application directory for the mean stack, they give you a script called use mean stack that basically runs an environment variable script. And this localizes everything, all of these commands, to this image that you have set up, which makes it really easy for you guys to install different versions of software and not have them conflict with each other. So let's go back and see if the application is deployed. OK, great. So I have a mean server running up in the cloud. And if I click that, I am actually serving this traffic. And I am running a mean stack on top of Bitnami. And I can also manage this inside the Google Cloud Console. So clicking on this will take me into our Cloud Console where I can go and view metadata about the image. I can view application logs. I can view a bunch of other things. And we also, they also integrate with our SSH terminal window, which is pretty cool. So just with a click of a button, I can either download the SSH keys and run it from my local machine, or I can connect to this instance and have a terminal window running right in the cloud for me to go and install software, execute commands, or get my application up and running here. So we're really excited to offer this partnership with Bitnami. I'm really happy to have their expertise in handling the images, keeping them updated, optimizing them for our cloud, and making it such a simple, lightweight experience to get started. So we'll go back to the slides and talk about Compute Engine and how we're using it in our application. So I mentioned that Compute Engine is just a virtual machine technology. The reason why we're using it for our app is we wanted to, as we take these images, we put them in cloud storage, and we need to resize them. We need to optimize them for a mobile device. We're going to actually use a third-party library called ImageMagick to do this. And ImageMagick is written in C, which is not runnable on top of App Engine. So we need to go and spin up our virtual machine, run ImageMagick, install the software, and then hook it up to our cloud storage service. And we're going to do all of that in the Build Your App session later on today. Now, I've covered both the infrastructure as a service and the platform as a service offerings. And typically, it's a trade-off between flexibility and agility. But as you've started to hear from the keynote today, we really want to offer a world that gives you guys both of these technologies. The big pain point has always been people wanting to move between management of virtual machines to something that's a little easier like App Engine, or going from App Engine all the way to something like our infrastructure as a service product. And we think of this as a continuum, a spectrum, and containers are really the glue that binds everything together. So on the left-hand side, we have our virtual machine products, and this allows you to run anything, but you are going to be managing this all yourself. And we want to make it super simple for you guys to take that, put it into a container where you have a static set of binaries with their own dependencies. You can run that locally. You can push it up to production. Or just let us manage everything for you and move all the way over to our platform as a service offering on App Engine, where we give you everything, and all you have to focus on is building the app. But we also want to make it simple to move and transition between these two states as the needs of your application evolve. And I'm not going to cover the Kubernetes stuff too much because that's going to be in the other compute session that's going on now. But I did want to give a call out to what we're thinking about as the next generation of App Engine. And this is App Engine, and it's called Managed VMs. And we announced this in GCP Live 1.0 back in March. And really what this is App Engine running inside Compute Engine, inside of a container where you can have a portable unit that you can transfer between the App Engine world and the Compute Engine world. And this really gives you the flexibility of taking the core components of App Engine and then adding the extra stuff that's missing to your app. So if you want to run Node.js on top of App Engine, you would use Managed VMs in order to do that. And the team's been really hard at work. They've been working on load balancing support for Managed VMs. They added some auto-scaling service. They integrated with our Cloud SDK. And while we had an alpha back at GCP Live 1.0, we are now moving to beta, and Managed VMs will be open to all as of now. So that's a general overview of the computing products that we have on top of Google Cloud Platform. Once again, we're using our Abelana server running on App Engine, which will handle the main request from our Android applications. And then we have a Compute Engine VM running in the background that goes and resizes and processes images as they come up. But that's really only one piece of the puzzle. So we have our compute system, but now we need to think about where to store our data, because an application really isn't complete unless it has some data to store and interact with. Google Cloud Platform offers a number of different storage options for you guys. So we have everything from our NoSQL, highly available product called Cloud Datastore. We offer a fully managed relational database product called Cloud SQL. We have our blob storage service, Cloud Storage, which is used for uploading binary files, large amounts of data, or serving static websites. And then we finally have our block storage option running under a computer engine called persistent disk, which allows, it's basically just storage for virtual machines. And we have a few different variety of options for you guys to decide on what type of persistent disk performance you need from your application. And the Abelana app uses 3 of these, so we're going to be actually covering Cloud Datastore, Cloud Storage, and persistent disk over the course of the day today. So first, let's talk about Cloud Datastore. It's a fully managed, schemaless, NoSQL storage for non-relational data. It's a bit of a mouthful there, but really it's a lightning-quick set of storage for your application. It was originally built to interact with App Engine. App Engine needed a place to store data. Cloud Datastore was the perfect fit. And I get the question every once in a while, it's like, well, why don't you guys have a relational data model called Cloud Datastore, where I'm using similar concepts than what I'm used to. And quite honestly, we had to build something that could scale. If you think about what the purpose of App Engine is, it's really about letting it scale your application as simple and easy as possible. And we needed a database that supported those types of scalability constraints as well. So, but we realized that not everyone was familiar with NoSQL. We had introduced this a few years ago. And so we also give you a little bit of the best of both worlds in that you also have a SQL-like syntax for querying data that's stored in Cloud Datastore. And as I mentioned, we needed something that scaled. We actually built upon a lot of the technologies that we use inside Google. So Bigtable and Megastore are 2 papers that we've released. They're 2 technology products where we've published papers on the internal architecture. And these are massive distributed scalable storage options that we use for all of the products for a lot of the products that we run on top of Google. And this is actually what Cloud Datastore is built on top of. So as long as you guys don't build apps that scale more than the apps that we have, you guys should be fine with the performance of what you get on Cloud Datastore. So we don't have time to go into a full breakdown of SQL versus NoSQL, but I did want to introduce some concepts because we are going to be covering this later in the session, later in the track. And I want you guys to at least be ramped up on the types of terminology that we're going to use. So in terms of Datastore, you still need to have a type associated with the type of data you're going to store. And this is pretty similar to a table in a relational database model. So it's called a kind. And so you would specify a kind of data that you wanted to put into Datastore. And then the actual data that you want to put in there is called an entity. And this is analogous to a row. Every one of those entities need to have a unique key. And this key can either be generated by you guys, or we will generate it for you automatically and just assign a numeric value for that. And then the data of the entity is the set of properties that you want to store with it. So this is a list of key value pairs that allow you to attach metadata about the information that you're storing. So just to give a quick example, imagine you're running a social application and you want to store some data about blogs and the number of users that you have on there. The kind is the type of data. So this would be a blog entry, or it would be the users that you have. The entity itself is the actual set of data that is going into the data store. And within that entity, everything has a unique key. So it can either be a number or it can be a value that you assign. And then below that are the author, content, and data, the properties of that data. And one of the interesting things about Cloud Datastore is that you can have multiple values for each of these properties. So if you actually look over at the following table, you can see that I'm following 2 people. And in a normal relational database model, you would typically have to set this up with 2 servers. You would have, or 2 database tables. You would have your users table, and then you would have a table describing the relationships between users. But Cloud Datastore allows you to append multiple values to a single property, which makes it really fast and easy to query and get information out of Datastore. This is a quick little example of how to interact with Datastore. We're going to be covering more of this in the next section, but this is actually written in Go, and it's a really simple API for defining the structure that you want to go and put into, the entity structure that you want to put into it, and then we go through an example of actually putting it into our Datastore, creating a new key for it, and this is just I just wanted to give you guys a high-level overview of what it looked like. So what are we using Datastore in our application today? Well, makes a lot of sense that we're going to be working directly with the Abelana server and Datastore together. So it's going to be housing all of the metadata that we have about the pictures in our application, where they're located, and what type of upvote information is contained in those. It's also going to talk about who is following who. All that information is going to be set up as relationships inside Cloud Datastore. But the other thing we need in our application is a place to store our photos. And this is where Google Cloud Storage comes into play. So Cloud Storage is our blob service offering. Its primary goal is to store large files on the cloud. And some of the nice features that you get out of the box with it is, one, a choice of availability. So what this means is if you have data that can tolerate a little bit of failure, like let's say you are doing some data backups or you have a batch job that can recover itself if it ever goes down, we give you the option of not only our standard cloud storage offering, but our durable reduced availability option. This is just a much more cost-effective solution for people that can tolerate a little bit of failure and regenerate data. So you have some flexibility in the type of storage that you choose on top of Google Cloud Storage. The other great thing is that it's fast. It's really fast, especially for building global applications. All of it is built on top of Google's network. And we do edge caching to ensure that your users, when they're retrieving content, they're always pulling it in from a local machine that reduces latency as much as possible. The next thing is that we give you guys server-side encryption out of the box. So everything is encrypted at write. You guys don't have to do anything extra to go and set that up. And then finally, there's a lot of powerful access controls and OAuth 2 restrictions so that you can actually partition off not only the buckets, but the data inside the buckets to different users, different ACLs, or different service accounts. And I sort of mentioned this before with our global edge casting, but one thing to note about about cloud storage is it has strong global consistency. And what this means is that when you upload a file to Datastore, it's atomic. You actually won't see the file until it's completed uploading, but once it's uploaded, it's available everywhere. So as soon as you upload a file, you won't get any 404 errors. It's automatically streamed out to all of the different storage options around the globe. So this makes it really simple and easy to do static site hosting or file hosting. And then another question I get a lot, and this is more of a when should I use this, or what is the right appropriate time to use Google Drive versus Google Storage? Drive is really it has a set of APIs. It allows you to upload files, but it's really a file synchronization service that's built for apps. If you are doing sharing with other people and you want to integrate with other types of applications built on top of cloud, then you really want to use Google Cloud Storage. There's just so many APIs and endpoints that make it super simple to use Google Cloud Storage from App Engine. We offer direct streaming from BigQuery directly into Google Cloud Storage and vice versa. So it just plays really nicely with all of the products we've built on top of Google Cloud Platform. So what does it look like to actually go and work with it? Pretty simple syntax. I've just given you guys a list of commands. The gsutil command is included inside the Cloud SDK that you guys can go and download. And the first one is just a make bucket command, and I make 2 buckets, cats and dogs. Now, something I wanted to call out is that every bucket name needs to be unique across all of Google Cloud Storage. So this is likely going to fail. There's probably a cats and dogs bucket out there somewhere. So just keep that in mind as you're building your app. Just pick a unique name. The second example I wanted to call out because it's an option that not many people know. So you can copy up files to the bucket, but the -m flag when you're using it allows you to do asynchronous copy, so it won't block on it, which is just a really nice feature of gsutil. And then finally, you can use the gsutil command to actually set ACLs directly from your command line. And as I mentioned, this is the perfect option for storing our images. So when a user uploads the image, it's going to go and process it in Compute Engine, and then it's going to store the optimized version of that back inside Cloud Storage. So we actually will end up with 2 buckets. We will end up with the incoming images, and then we will end up with the processed and resized and ready-to-go images. Now, the last thing I want to talk about is persistent disk. And persistent disk is disk storage for your virtual machines. And the thing to note is that it's not just a single disk that it's attaching to. It's actually a network array of disks. So this gives you the flexibility to attach multiple disks to a VM or multiple VMs, multiple instances to a disk if you set it up in read-only mode. And some of the nice features about persistent disk technology is we give you guys a lot of space to work with. So you can spin up up to a 10 terabyte persistent disk, and it'll work just fine on top of our platform. And we actually scale performance with size. So as you start to go up the chain for size, we increase the throughput and we increase the IOPS that you get out of PD. And I'm going to talk a little bit about that next. And just like cloud storage, we encrypt on the wire and at rest. So your data is secure, it's encrypted on top of our persistent disk technology. So what is the right option for you? Well, we offer 3 different choices of persistent disk to spin up with your virtual machine. The first is our standard persistent disk offering that is a cost-effective storage that can be attached to any number of VMs. This is really good for early stages of product, boot volumes, anything that's doing streaming I/O. It's just a nice performance choice for actually building out your application from the beginning. But if you have certain types of applications that have higher I/O requirements, you need to move up to our SSD persistent disk. So this is our solid state offering. Really offers a nice array of I/O for the amount of storage that you get. This is what you would typically use for something like running a MySQL database in production, or running a typically more advanced type of software stack that requires a lot of high I/O. And then finally, we talked about this in the keynote today, but we're just announced support for local SSD. This is our lightning fast flash storage that has amazing performance and can be attached to a standard high CPU or high mem VMs. So this is the perfect solution when you need really, really high IOPS. And this would be for running things like a Hadoop or Cassandra cluster. Now, one thing that's a little bit unique to Google, and I wanted to cover it briefly here, is that we scale our IOPS and throughput with the size of the disk. So here's a graph showing the performance characteristics for a read and a write operation on our standard PD and our SSD PD. And one of the things you can see is that SSD spikes up really quickly and then tapers off. This is actually, we're reaching the physical limits of running inside this virtual machine at the amount of IOPS that we can get. So we're not really contained by bandwidth as much as we are just hitting the max limits of what the VM can support. So people have asked us why we do this. Why do we scale performance with size? And a lot of it really comes down to the ability for us to give you guys consistent performance. So by selling I/O and space in a safe ratio together, it makes it easy for us to plan, to partition off, and to give you guys consistent traffic, which means that you guys don't have any noisy neighbor problems. Everything will run smoothly regardless of what other apps are running on the disk rack for you. The second is that it gives you simple and consistent pricing. So if you guys ever need more IOPS, you just create a bigger disk. And the nice thing about this is that your charges don't vary with the amount of IOPS that you hit with your application and have them changing over time. It's just a really nice, consistent model. Your bill is going to be the same from one month to the next that you have. And then finally, it's just really easier to work with. Back when we first announced persistent disk and we didn't scale with size, in order to achieve higher throughput or higher IOPS, you actually had to go in and stripe smaller disks together. And we found that this just added a lot of management overhead for getting the fastest application performance. So by now scaling with size, you just create a larger disk, you get the IOP increase, and you don't need to worry about manually going and striping the disks in that array. And it also makes it really easy to snapshot because you don't have to stripe, everything's stored on a single disk, so taking a snapshot is just taking an image of that disk and storing it off. So as I mentioned, compute engine, we're going to be using persistent disk here. It's going to be running an operating system. We're going to install ImageMagick on there, and that's going to be using our standard persistent disk offering for this demo. So that's hopefully that's a good broad overview that sets the stage for the rest of the day. I just wanted to give you guys a brief intro to some of the products that we're going to be using and talk about what's next for your application. So as I mentioned, stick around for the other sessions. The next one that's coming up after this is going to be the Build Your App session, and that's where we're going to be taking the app from start to finish, or it's going to be really demo heavy. And the next one after that will be Deploy and Operate. We're going to push the application to production. We're going to show you some of the cool features you guys have for version traffic splitting, using some of the DevOps features we have, like logs to source. And then finally, the last session is going to be around, it's going to be our big data session, Optimize and Analyze. So this will be where you can come in, take a look at logs, pipe that data into BigQuery, run a few queries over it, generate some insights, and then use that to tune your application. And we sort of called this out in the keynote, but I wanted to just send you guys a quick reminder. Free trial, it's a new offering from us. You get $300 in credits, so go and start building today. Thank you guys very much.